If you want to hit record and we can, all right, we'll dive in. So welcome folks, we're gonna get diving in today. Welcome to our Kubernetes clinic. How much does Kubernetes cost? So if you're here for something else, this is what we're gonna be talking about anyways. Hopefully Kubernetes and cost in Kubernetes is something that's exciting to you. And if you're using Kubernetes, it is relevant to you, whether it's exciting to you or not. So let's start with introductions. Bill, you want to introduce yourself?
Sure. Thanks, Kendall. I'm Bill Lettingham. I'm the CEO at Fairwinds. Have been on board for 3 years. And in my previous role as CTO at my former company, had a number of challenges on this topic. So hopefully get a chance to share some of the challenges and solutions today with all you folks. So appreciate you all joining.
Thanks, Bill. Robert, you want to intro?
Yeah, I'm Robert Brennan. I'm VP of Product Development here at Fairwinds. I've been working on building products, both open source and commercial, focused around cost and Kubernetes.
All right. And hey, folks, my name's Kendall. I was the first hire at Fairwinds. I've been here a very long time and now working as a tech evangelist, and excited to talk about this today with y'all. So let's dive in. And real quick, I'm assuming if you're joining a Fairwinds Kube Clinic, you've probably heard of us, but at a high level, we are a Kubernetes company. We build software for security, policy, governance, so that customers can ship software faster and more effectively with less risk in the cloud. That's our goal. And we really care about simplifying that complexity. So our history is as a services organization, building and running Kubernetes clusters for people, and we pivoted to software after seeing that we can run the world's most hardened Kubernetes clusters, and if what everybody is deploying into them is terrible, it's not secure, it's not reliable, it's going to fall over anyways. So today we build software to help people avoid that problem. Everyone's still adjusting to Kubernetes. Everyone's afraid they're doing it wrong. Probably some significant percentage of those people are doing it wrong. We build software to help give confidence that they're using it correctly. So that's who Fairwinds is. And as a result of that, some of our software addresses Kubernetes cost, and that's why we're having this webinar today. So we'll get into some of that. We'll show you what that looks like in a few minutes. But first, what is your greatest opportunity to improve your Kubernetes environment? And thanks, Dave, pulling up that poll. If y'all can respond, we collect this data over time as we do lots of these webinars, and try to aggregate how those things improve or change over time. So love to have your feedback. You need help getting help with the basics, getting a general best practice assessment, improving the security posture of your clusters, saving money, or improving the reliability of apps running in Kubernetes. And I'll take a minute and let folks answer. Robert, when I pause, I feel like you need to automatically go into Jeopardy music. Like, we do enough of these together.
I was going to say, I wish I could vote, but it's not letting me as a panelist.
Yeah, different platforms. We do these on some different platforms. Sometimes we do them with a third party, and then I get to vote, but not today. Okay, we'll give that just another second, and then we'll wrap it up. 5, 4, 3, 2, 1. Okay. Thanks, Dave. And let's carry on. So let's dive into the cost of Kubernetes, and I'm gonna turn off my slides here, and we'll come back towards the end, but leave this as more of a discussion as we go through. So let's back up first of all to why do we even care about the cost of Kubernetes? And Bill, you mentioned, this has been a problem before when you were CTO at other places. Like, why do we care about the cost of Kubernetes? And maybe it's obvious, but I feel like we should talk about the obvious.
Yeah, no, I think the good news is, Kubernetes is becoming more and more popular. More companies and organizations are running workloads in Kubernetes environments. And because of the flexibility by which you can deploy applications, scale up applications, et cetera, obviously Kubernetes has a number of advantages. But part of the challenge is because companies are using it more and more, the associated cloud spend around their Kubernetes environments continues to increase. And as a result, financial teams within these organizations are asking the development teams, well, can you justify what you're spending in the cloud and how much of it pertains to this application versus that application? And as we add more customers, what does the future look like in terms of the cloud spend? And so dev teams are really being kind of forced to answer a number of these questions because of the usage of Kubernetes and how much flexibility there is in the infrastructure there.
Yeah, and I imagine there's some there's some reality that, just like you mentioned, the more that workloads are running in Kubernetes, the larger percentage of the infrastructure this spend is. And probably there are a lot of organizations with CFOs that are like, wait, what's this Kubernetes thing? Why are we spending so much money there? And like, can't you just make that cheaper? And particularly as a CTO, if you know that it costs you this much money to develop this feature, or that this particular feature generates almost no money for the company, but you see that it's costing all of this money to run, like that's a stress for you, and being able to have some visibility into that probably matters. So let me ask, I mean, the next question related to that is, there's a whole bunch of cost solutions out there. What makes Kubernetes different? Like, can't I just look in AWS and see my bill and understand what I need to do with my Kubernetes infrastructure? What's different?
Yeah, I think here again, the challenge is the different kind of architecture that Kubernetes has versus the historical approach to costing in the cloud was really look at kind of the amount of compute resources where you could kind of directly tie applications running in VMs to a particular number of compute nodes, if you will. Whereas within Kubernetes, it's much more of a black box where as you deploy workloads into Kubernetes, you can't really break down by application or by workload what kind of percent of the underlying infrastructure that workload is actually using. And I think in addition to that, just there's some challenges with how cloud native applications are being built to leverage a number of different microservices. Those microservices could be running across one or more Kubernetes clusters. Being able to kind of attribute the cost of each of these microservices back to kind of a higher level of construct like an application, becomes a challenge as well. And so it's really this notion of kind of getting visibility into the black box of Kubernetes, being able to attribute different costs to different applications, and especially in more complex environments, being able to kind of sum up those different costs across the different elements so you have a more holistic view as to what your spend is on a per application basis.
Yeah.
Yeah.
Yeah, and I think, I mean, I would add too, like, when you owned your data center, when you had a server room in the closet, you knew exactly what your cloud spend was. It was whatever your computers cost you and whatever your internet bill was, right? Like that was it, because you controlled the whole thing. The problem was you had to have enough computing power to manage your largest workload or your largest traffic days ever, right? And the beauty of the cloud was that you could move things there. You could be some small shop, scale up overnight. You didn't have to go buy 1 billion computers. And when Black Friday comes along, you just tell Amazon, hey, I need more computers, and you scale them up and then you scale them down when you're done. Surprising number of people that I've talked to over the years use the cloud and don't use auto scaling. And I'm always like, why? Like, what? That's the whole point. But now Kubernetes does a whole bunch of that for you, right? It actually scales things up, scales them down. A lot of times you can set no instructions when you give a workload to Kubernetes and it'll still do it for you. It just might do it really poorly. And to your point, it's this black box. So the beauty of the cloud was we now had this ability to scale things up and scale things down. You could use it wrong. You could run in the cloud at full capacity all year long. Same thing with Kubernetes. It's one more layer of abstraction that makes it easy to scale up, to scale down, and you can still use it wrong and scale all the things all the wrong ways and put workloads in it that are horribly misconfigured and cost you a fortune when they don't have to. So like on the one hand, the cloud and Kubernetes have this incredible promise for making your actual usage really match your spend, or making your spend really match your actual usage. But you can use it in a way that is worse than even paying for all your own hardware and just running it all the time in your own server closet, which is, I think, amusing and very ironic. Were you going to say something, Robert?
Yeah, no, that's a great point. I think one of the things that is really difficult about managing spend in Kubernetes is that it is really easy to mess up your settings and end up, basically asking for more memory and CPU than your applications actually need. Not having a real sense for, how well your usage actually matches the CPU and memory settings that you put down, and not really measuring how your workloads are fitting into physical machines is a good way to just end up with a ton of idle CPU and idle memory that you're paying for but not actually using. And so you really need to be able to introspect the Kubernetes cluster in order to see where those gaps are, where that waste is. If you're just looking at the AWS bill, you're not going to be able to see it.
Yeah, I think that's a very important point, Robert. Kubernetes will scale up the amount of underlying resource as to kind of what the workloads are asking for.
Yeah.
And so if you have a workload misconfigured to ask for too much CPU or too much memory resources, Kubernetes will just simply comply with that request. And as a result, you'll over provision the environment and waste, cost, if you will.
Exactly.
But wait, Bill, don't I just configure things correctly? How hard can it be? I mean, why is that so hard? Why is that hard in Kubernetes?
I think the big thing.
Well, just looking at my own experience managing dev teams, I find a lot of times developers will just want to simply get an application running, and they want to make sure that it has plenty of resource so they can kind of eliminate lack of CPU or lack of memory as a reason why it's not running correctly. And so out of the box during development, they'll purposely over provision a workload just to minimize that potential problem from occurring. But a lot of times then they don't go back and fix those resource settings as they go to deploy that application in production. And so consistently we see many applications being over provisioned 25-30%, just because that that rationalization process hasn't happened to go back and make sure that those resource requests and limits are actually set appropriately.
Yeah, I think you're totally right. I think it's a matter of incentives, right? The dev team is incentivized to make sure it works, make sure it doesn't crash. They're not incentivized to save every penny, and so they do end up over provisioning sometimes by quite a bit. And the other issue is that it's also a moving target, right? Your application's changing over time. The amount of memory it needs might change over time. The amount of CPU it needs might change over time. The amount of traffic you're getting is changing over time. So you constantly have to be looking at your CPU and memory usage relative to your settings and deciding, are these set properly? I would say, as often as every month, but at least every 3, 6, 12 months, you need to be looking at your actual usage versus your settings and truing that up.
So this is going to be a little bit of a tangent, and it's a ridiculous story, but I think it illustrates some of what the two of you were talking about. My first job in tech, while I was still in college, was at a small tech startup that had grown up really big and then shrunk down really small. We did have the server room in the back that I'm joking about as mythological, even though it's it wasn't that long ago. Anyways. One day, one of the most senior developer and I were fiddling around with a machine, and we were like, hey, this thing has a motherboard that allows for 7 Xeon processors, or I don't remember how many. And we're like, and we've got all these computers sitting around in the office. Let's see what we can do. So we start pulling these computers apart and just trying to plug processors. I don't remember how many it was, 2 or 3, that we plugged into this machine just because we could. And because we had a little bit of extra time and we wanted to see what we could do with a machine this powerful. Well, when we turned it on, we fried all of the processors, which basically made 5 computers in the office completely destroyed. And they were all expensive units. And we were very embarrassed. It didn't matter because the company was shrinking and going out of business anyways, and we never needed those computers again. that's neither here nor there. But my point being, you give developers some computing power and some free reign, and bad things happen. And that was even a long time ago when there was no way to pick a M1 or whatever the biggest things are that you can click button have in Amazon these days, and let alone with Kubernetes, where I can literally just be like, I don't know, I wonder how much I can turn these dials to 11. You want gigabyte limits? Let's put 6,000 in there and see if it works, and like literally nothing stops it. So, I mean, how far off am I on that, Robert? You're the closest to that. Developers do that kind of stuff.
For sure. Yeah. I mean, when you're launching a new application, you've never really seen it with a production load yet. So you're just making a guess, and you better guess high, because if it's too low, then you're going to see real issues. Like users are going to be angry. If it's too high, you might eventually get, an angry email from the CFO, but that's very different from like your users not being able to access the app. So I think it actually does make sense on day one to over provision, by as much as 100%. But then, you have to, go back and look at it and see, okay, what does the actual usage look like, in the next day or two, and then, pare back those settings based on what you're seeing in reality.
So talk about that, Robert. I'm Joe developer. I built a thing. I think I've over provisioned it a little bit. How the heck do I find out? Is there tooling out there that you can point me to? I may or may not be teeing him up to talk about one thing specifically, but yes, please tell us how to make this work, Robert.
Yeah, so there's a few different layers of tooling you can look at here. One is you can just go right into the command line with kubectl and look at if you have metric server installed in the cluster, you can look at the actual memory and CPU usage for each individual pod, each container running inside of the cluster. You're only going to see kind of a point in time snapshot there, which isn't super helpful. If you want to get a little bit more complex, you can check out an open source project that we produced called Goldilocks, which will look at the memory and CPU usage over time and make recommendations for what you should be setting your settings at, depending on your desired quality of service, right? If you there's a little bit of human judgment here, where if you've got like a production user facing workload, maybe you do want to over provision by 10, 20%, just to make sure you always have enough and you don't mind spending a little extra to do that. If you have a workload that's just, a development workload, it's just an ephemeral deployment to test things out, maybe you under provision that a little bit in order to save some money because you're going to have 100 of them or something like that. So Goldilocks lets you basically pick a desired quality of service, and you can set your CPU and memory. It'll give you recommendations for CPU and memory settings based on that. And then even one step further would be to look at our commercial software like Fairwinds Insights, which will track a very long period of usage here. It'll show you the graph of memory and CPU usage over time, so you can make judgment calls based on what you're seeing in terms of spikes and things like that. You can kind of take seasonality into account, and it will also provide recommendations for what your CPU and memory requests and limits should be set at based on the historical data.
So talk for a minute about, before you talk the commercial software, how do I operationalize Goldilocks? Like what does that actually look like? Do I install it per workload? Do I run it on my local machine and it tells me? Do I run it in the cluster? And do I have to do this for every single workload? How do I do it across 10 clusters? Like how easy or complicated is that at scale with Goldilocks and open source?
So Goldilocks typically runs against a single cluster. You can, if you install Goldilocks on your command line, you can run it. It'll pop open a dashboard and it'll show you for every workload in that cluster what you should be, setting your CPU and memory requests and limits to. So it's a little difficult to run it across clusters, and generally a lot of the open source tooling out there tends to focus on a single cluster, and so running it across a fleet of clusters and aggregating all that data into one place is difficult, especially if you've got the same workload in multiple clusters. Maybe you've got EU clusters and North America clusters, or production and staging, things like that. It's hard to see all that data in one place. And it can be hard to track that data over time too, right? Goldilocks pretty much provides it's looking at historical data, but it provides you with a point in time set of recommendations. And it can be hard to say, track who's applied these recommendations, what teams are responsible, like if you need to assign out an action item to somebody to fix this particular workload. Maybe it's a development team that's responsible for it and you're a DevOps engineer. You want to put that on their plate to do it. So a lot of the commercial software out there, like Fairwinds Insights, will leverage open source like Goldilocks under the hood, but add a whole bunch of extra capability on top of it to help you run it across clusters, to help you track findings over time, to help you manage those findings, get alerting set up in Slack or Jira or wherever else. Basically all the kind of extra lifting that you would have to do just from looking at the dashboard that Goldilocks provides out of the box.
Yeah, you say a lot of commercial software out there marries these. I don't know of other commercial software because what we make happens to be the thing that solves this problem. But I appreciate that there is hypothetical software out there that also commercializes or operationalizes Goldilocks at scale. So to say back to you, let's say I'm a large payment processing company. Cough, cough. Clover is a customer of ours that is a large payment processing company, probably has times of the day where there are lots and lots more transactions, probably is operationalizing across lots of clusters and not just running on one Kubernetes cluster. So Insights is going to make it easier for me to both install something like Goldilocks, get the insights out of Goldilocks and some proprietary things above and beyond that, across all of my workloads, across all of my clusters. But also, to your point, I think it's significant. It'll collect and aggregate that data over time so that I get better recommendations that aren't just point in time. Point in time is significant, but particularly if you have any kind of variability in your workloads, it's really nice to collect that data for a while, see what it says, and then go make decisions accordingly, right?
Yeah.
I'm thinking of a number of different organizations that we've worked with in the past that have really, really fluctuating workloads, like 2 hours a week or 2 hours a month, or, we worked with one company that was related to elections. So we're talking like 3 days every 4 years, or whatever was like when they blew up huge. So it's nice to have some aggregate data when you're dealing with those kinds of fluctuating workloads, but
Yeah, no, the seasonality can go from, inside of a single day, maybe, from 9 to 5, you have peak usage, and then at nighttime it goes down during US hours, say. It can be, on a weekly basis. Weekdays might be bigger than weekends or vice versa. It can be on an annual basis. Black Friday might be a big event for somebody, and it can be, like you said, every 4 years if you're running on elections. So it's a huge range of potential seasonality in the data.
Yeah. Okay, so one thing I want to touch on is how cost affects other things in an organization. And Bill, you're the CEO of this organization. You've been high up in other organizations. When I'm poorly managing my infrastructure costs and they're running wild, that's going to affect my security budget. That's going to affect my hiring budget. That's going to affect how fast I can iterate, beat my competitors. Like how does this actually affect other things? And is cloud spend so small that don't worry about it. It doesn't matter. What's happening in Kubernetes is, doesn't affect my business, or can you talk about how some of those things marry together?
Yeah, no, cloud spend always by its nature starts out small and then can quickly accelerate. And so really you want to get visibility as it starts to accelerate, and then hopefully bring it under control, so that it doesn't eat into other areas of your budget that you have to address, like security, et cetera. And so think of it as, kind of free dollars that you can find by correcting some of these problems earlier in the cycle. Yeah. Also, frankly, a lot of it plays just into good hygiene around how you manage dev and test environments as well. I found in a number of, situations, developers, because it is so easy to start up workloads in the cloud, they'll spin up different tests, they'll leave things running and not remember to go back and delete that application or delete that test, etc. Yeah. So just even by having better visibility as to kind of what's running in your dev and test environment, you can kind of quickly cut out cloud spend that it is in essence wasted resource, and you can recover that to spend on other areas that are more important, frankly.
Yeah, and I think one interesting thing about cost savings software, so be that if you go install Goldilocks today and it's free software because it's open source and you save money, like that's a big deal. It costs you nothing but a little bit of time, right? And time that you probably needed to invest anyway. If you go buy something like Insights, which we're going to show you in a minute, and it saves you enough money to pay for the software, you don't have to even have an ROI discussion with anybody, right? Like, I mean, it's so many software decisions are like, well, do we have a big enough need to justify this? And sometimes when your infrastructure spend is big enough and things are poorly enough configured, and I'm not saying it'll be the case for everyone, but there's situations where we come in and talk to a company and in a proof of value show just how much money we're going to save, and it's almost just a bad decision to not buy the software, which is, you know, a nice to have, because not a lot of software sells itself quite the same way. But well, anything I'm missing here before I dive into showing what Insights actually looks like and helps folks get the cost of Kubernetes under control?
No, I think it makes sense to dive in and, you know,
Okay.
give a little more context from, you know, the look and feel.
Yeah, let's do it. So yeah, we like to be clear, we build software that helps people understand the cost of what they're using and what they're doing in Kubernetes. And we're going to show you some of that today. I'm going to give you a high-level overview of Fairwind's Insights and several different things it does, because it doesn't just play in the cost side, but we're gonna spend a little bit in the cost bits as well. So again, this exists. Fairwind's Insights exists to help companies with governance from CI/CD through to production in Kubernetes, and that's because, like I mentioned, everybody wants to be using Kubernetes the right way, right? They want things correctly configured, both for security as well as for cost. And most companies don't know how to get started on that. It's a new enough paradigm, they still haven't figured it out. They don't have the confidence that they know what they're doing. So that's why Fairwind's Insights exists. We cover security, give you visibility into risk, security risks, compliance problems that you need. We talk to you about over-provisioning and wasted resources. And we put in place policy and guardrails. And this is really a key piece. It's one thing to have one more dashboard in your life that tells you all the things you're doing wrong. It's another thing to have guardrails in place that keep you from doing things wrong, right? I've been married a long time. And when my wife tells me I'm screwing something up, it would be real nice if I had some kind of alert that stopped me from screwing up in the same way in the future. Because a lot of times I'm like, give me more examples, give me more examples. Oh, yeah, okay, but you don't know until you've messed up and messed up and messed up and messed up. And it's nice in life to just have guardrails around things. And when you're deploying into Kubernetes, your software deployments do not have to be like my marriage, where you learn everything the hard way, because with good guardrails, you can avoid that. So let's jump into a demo. When you log into Fairwind's Insights, you're going to get an overview of, this actually isn't the page that you'd log into. You get an overview of some of the main things that are going wrong in your cluster. But I've clicked on clusters here, or in your organization, and here's a whole bunch of clusters running in my organization. So my favorite cluster is offline, which makes me sad because it's my favorite cluster. But we have a whole bunch of other clusters running here. You can see that we give an overall health score across all of these organizations. We're showing you all the action items that are need to be addressed. And then over here, you can see we have an overall health score for the organization. So right now we're doing pretty good. We have an A. We have checked an awful lot of things with Fairwind's Insights, and 32,000 of those things are passing. Then we have some critical issues that need to be addressed. So I'm going to click into a cluster. Actually, I already have it loaded up right here. That talks you through, shows you where action items are being introduced into the cluster. So anything above the line here is action items being introduced to the cluster. Anything below is when we've knocked things off and we've reduced the number of action items in the cluster. And we track this health score over time. So in theory, we're improving. We were at an 89 and then got up to a 93 over time. And then we have some cost analysis going on here as well over the last month. So you can see it looks like we shut the cluster off for a little while there in the interim. Where are we getting this all from? If we go into the install hub here, what Fairwind's Insights is doing uniquely is marrying together a whole bunch of open source. And I'm going to get to the cost bits here in just a second. I just want to paint the picture for the big problem we're trying to solve. This open source is stuff that Fairwinds has released over time. So Polaris is an open source project that we wrote a couple years back that addresses just common misconfigurations. Lots and lots of issues that we see people commonly make these mistakes in Kubernetes. Let's write software to address that and help people avoid them. So that's why Polaris exists. But we also have Nova, which is a Fairwinds project that checks for Helm charts that are out of date. Pluto checks for deprecated APIs. We also have Goldilocks down here that gets memory requests and limits set just right. And you can see that that one's uninstalled on this particular cluster, and we'll get into that in a second. But there's a bunch of other open source projects here as well. So KubeHunter, KubeBench, Trivy are all here, scanning for known vulnerabilities, some best-in-class third-party software that we didn't write, but are also open source tools that help audit Kubernetes clusters and the workloads that are running in them. We also have support for open policy agents, so you can write custom policy. So there's a lot of things that we address out of the box because we marry together all these projects, but often organizations need to go write some custom policy to address something that's not already there. And we roll that all up into a big list of action items, sort them by severity, and then tell you, give you some high level stats about your organization, how many of this issue or that kind of issue you have running in your organization, the top namespaces with problems, and then any of these we can click into and it'll say, here's the problem, you have something running with a known vulnerability, here's how you go about fixing it, right? So that most of the security, most of the critical issues tend to be security related, but you can sort by criticality, you can sort by security, reliability, efficiency, et cetera. But let's dive in, since this is a cost bit, and show you what some of our efficiency metrics look like. So this is where we're getting into some of the cost bits. So comparing across the clusters in our organization, what cluster is costing us the most or using the most CPU or memory, and these clusters are pretty similar in size, so you're not seeing a massive difference. But down here we've got cost following these things along, so you can see dips and fits and starts across our organization, following some similar trend lines, utilization over time. And then I can go into any one of these clusters and get some, let's go to Proxima Prod, get some specifics unique to that cluster. So this is the total resources available to us in the cluster, total resources requested, the cost of actually running this cluster over time. So it's a cheap cluster because we use it for demo purposes, so we don't want to charge all the money for our demo purposes. But you can see that this tracks that over time, and you can correlate this with certain events, certain deployments in your organization, whatever it is that helps you understand what's driving these cost changes. And we can come into workloads, and this is where we break down by workload how much each thing is costing you. So here I'm going to sort by workloads that have recommendations. And the way we're approaching this problem is we want to help you set memory requests and limits to be just right. That's why it's built on top of Goldilocks, that open source project, Goldilocks, to get things just right. And so there are situations where you can see some of these workloads. Trivy, for example, in this situation has 3 pods running on average, and we've said that it's a critical or guaranteed desired quality of service. So with it's guaranteed is what it's set at. With guaranteed set, we're saying this is what it's costing you per month, but we actually think you should be spending a little bit more. If the quality of service that you need really is guaranteed, we've given you some suggestions that say spend some more money. However, here's another one where we're saying you can save money, even though this is critical. You don't need to be spending as much as you are on this particular workload because of the way that it's set up. So I can click into this, and then we're showing the requests and limits that we have on this particular deployment, and then what we're actually using over time down here. And so you can see that those two don't line up. That's why we can move that target down a little bit, and you can take our recommendations. So here's what we're actually requesting, and here's what our recommendations are, and how that will affect things cost-wise. So this is suggesting slightly more memory, but must be significantly less CPU. Yeah, so that's where that money savings is coming from. Again, these are small numbers because it's just a demo environment. It's one thing if you have 3 pods running, it's one thing if you have 300 or 3,000 pods running of that particular workload. And if you're using a really big instance type, those kinds of things affect all of that cost. But this is the kind of thing, if you decide to check out Fairwinds Insights, we can set this up for you really quickly and start collecting this data very quickly and show you where some big wins are to be made in your Kubernetes cluster for cost. And okay, I just saw that there's a comment in the chat here. There is a Q&A in there if you want to ask questions as we go along, so please feel free to mention if you want to understand things. I'm going to show you a few more things about Fairwinds Insights, and then we'll come back and answer some questions if people have any questions. One of the things about this big list of action items is it can be overwhelming. And like I mentioned, being told all the things you're doing wrong isn't nearly as helpful as putting guardrails around things. So that's why we have this governance engine for our policy, and it integrates into things like CI. So here you can see Robert's trying to push some code into a cluster that's going to break some things. And you can see Circle CI has passed all these tests, but Fairwinds Insights has failed the deployment or failed this pull request, so that we need to go fix some things before we can merge this in and actually end up deploying this. So here we have privilege escalation that has been turned on and shouldn't be, and you can click into this and it'll tell you what's wrong, here's what the problem is, and then how to go about fixing it. So you don't have to be a super senior engineer to iterate on this. And in fact, the engineers at your organization that really understand Kubernetes can put in place this policy, put in place this governance, and then it's going to stop developers from doing bad things and empower them to go fix it, so that it's not just ops all the time that has to solve all these problems. You can shift that and stop just being a help desk for everyone that wants to get workloads up and running in the cluster. There's a lot more here. We have some compliance bits. We allow you to compare clusters to one another. You can write custom policy. You can create automation so that anytime something's introduced to the cluster, we kick off a ticket to say Slack or Jira. There's lots and lots that you can do with Fairwinds Insights. We're primarily highlighting those cost bits today because that's what the talk is about today. But we find that most organizations that want to control cost also want to control security issues from happening in their clusters. That's why Fairwinds Insights exists. If you want to know more, reach out. And we do have a white paper here for just getting Kubernetes correctly configured. Kubernetes, the good, the bad, and the misconfigured, which is a pretty great title. You can go check that out on our website. And yeah, Dave will send a link to everyone as follow-up in email. But I don't think I've seen any questions come through. Does anybody want to ask a question? I'm trying to think. Let me ask a question to tee some of this up while people think on if there are any questions. But like, Robert, let's say I'm already paying for something that to manage cloud costs, another software component that looks across my entire, let's say, AWS cluster and tells me how to optimize things. What am I going to get from Insights that I'm probably not going to get from that?
Yeah, that's a great question. So most of the cost software out there will look at your AWS bill, and it'll understand each of the line items on that AWS bill and help you figure out, who to charge each of those line items to. The tough thing with Kubernetes is that one line item on your AWS bill, which is probably like an EC2 instance, is getting basically chopped up by Kubernetes and distributed among different applications. So that EC2 instance might be running, one application from this team, one application from this team. And there's no way to tell by looking at your AWS bill or any numbers that AWS provides, how much of that node should be allocated to which team, or even which teams are running on that node. So you really need to be able to look inside the cluster to understand, how are those nodes getting divided up among teams, what percentage of them is going to waste, et cetera. So the difficult thing, I guess, to sum it up is that, it's no longer one line item on your AWS bill, getting charged to one particular team or one particular business unit. Now that line item has to get sliced and diced based on what's going on under the hood in Kubernetes. And what Insights gives you is that view into Kubernetes inside the Kubernetes cluster, so that you can figure out how to, cut up those line items on the AWS bill and divide them between teams.
Great. Yeah, so sometimes you need the specific tool. In theory, you can use a wrench to, unscrew something from the wall, but having the right Phillips head or something is going to make it a lot easier. And that's the situation here. Okay, well, I think we don't have any other questions coming through, and we can wrap up. But thanks, folks, for coming. This has been about cost in Kubernetes. And if you have any questions, please reach out. We have a team that's happy to talk with you about managing cost in Kubernetes. We're happy to set you up with a trial of Fairwinds Insights and see where you can be saving money right now. And if we can be useful to you, we'd love to do so. So thanks so much.
Thanks, y'all.
Thanks everyone for attending. Thanks.